By the end of this lesson, you should be able to add and subtract a given rational functions. That's addition and subtraction of rational functions. In our previous lesson, we looked at how to simplify them. So now we are going to look at how to add and subtract rational functions. So now, let's simplify the following to get better understanding under addition and subtraction of rational functions. So the first problem is we have to simplify x or negative 1 minus y or negative 1 over x or negative 2 minus y or negative 2. So this the first problem we have to simplify under addition and subtraction. So you see that we have x power negative 1 minus y power negative 1 all over x power negative 2 minus y power negative 2. So we have to take our time and apply some concepts from indices. So from indices, if we have a negative 1 is the same as 1 over a. This means that any number power negative 1 is the same as 1 over that number. So we are going to apply that concept to solve this problem. So which is equal to, from this side, x over negative 1 is the same as 1 over x minus y power negative 1 over what? Y. All over, we apply the same concept at the denominator side and we are going to get 1 over x squared minus 1 over y squared. Now this is how to change the negative powers to fraction form. Now let's move on and simplify both numerator and the whole denominator separately. So we are simplifying them separately. So now let's consider the numerator. Taking the numerator 1 over x minus 1 over y. We are taking this one. So when we take this one alone, its LCM is what? Xy. If the LCM is sy, so s goes into the sy, y times 1 get y minus get x. So this for the first part. And when you take the second part, taking the denominator side, 1 over x squared minus 1 over y squared. This one too, the LCM is going to be what? X squared y squared. And since it's x squared y squared, we will write xy or squared. So x squared goes into that, the remainder will be y squared times 1 y squared minus y squared going to here to cancel the y squared. The remaining term here will be s squared times 1 s squared. So now we see we have to take our time and simplify each separately. So now let's join them in the question. So we are going to get 1 over x minus 1 over y. The final result is what? Y minus x all over xy over 1 over x squared minus 1 over y squared. The final result we got is y squared minus x squared all over xy all squared. Xy all squared. So on this root, we can clearly see that when you have this over here, means that this numerator is divided by the denominator and can rewrite it as y minus x over xy divided by y squared minus x squared all over xy all squared. And on can also rewrite this expression as y minus x over xy times, then we find the reciprocal, the sy squared over y squared minus s squared. I hope it's clear. And this side is difference of two squares. So we can perform our difference of two squares and we're going to get y minus x over xy times sy all squared over. So since this side is difference of two squares, we're going to get y minus s, y plus s. So if you do it this way, then this is a factor, then you can cancel out. And here we'll do this power. So we are going to get here around sy, and here everything here has become to 1. Because this one will cancel this one here, and this one will cancel this one, and reduce the power to power 1. And our remaining resource is xy all over y plus x. That is the final result for this problem. So it's a matter of taking your time and apply the rule of indices to solve this problem. Thank you very much. So now let's move on to look at the problem number 2. Problem number 2. Problem number 2 says you should simplify. Problem number 2 says you should simplify r squared plus t squared all over 2 bracket r plus t all cube minus r minus t all over 2 bracket r plus t all squared. So you have to simplify this program, and on this note, you have to take our time. So you have to take our time and find the least common multiple for the denominators. Well, there's an operational sign here which is subtraction. So let's find the LCM for the denominators. You see that 2 here, 2 here, inside the bracket they are the same. But this power 3 is power 2. Meaning that you can find the second denominator in the first denominator. Since we can find it in the first denominator, then we have to take the first denominator as our LCM to solve this problem. So that meaning that the LCM will become r plus t or p. So 2 bracket r plus t or p goes into itself here 1. So 1, we have our 1, this is the 1 times r squared plus t squared. Bring your minus sign. So this 2, it cancel. So r plus t all squared goes into r plus t cube. It will do this power 1. So we are going to get r plus t power 1. I will not write the 1. Any number power 1 is the same number. Bracket r minus what? T from this side. So when this goes into this, you get r plus t times the numerator. So now let's move on. So 1 times r squared, we are going to get r squared. 1 times t squared is what? T squared. Minus brackets. You see, you have r plus t, r minus t. This difference of 2 squares. So since we have r plus t, r minus t, you can write it as r squared minus t squared, because it's the difference of 2 squares all over 2 bracket r plus t over 3. So which is equal to, we have our r squared plus t squared minus by r squared, get minus r squared, minus by minus is plus t squared all over 2 bracket r plus t all over t. And on this note, r squared minus r squared is 0. So t squared by t squared, we are going to get 2t squared all over 2 bracket r plus t cube. And these 2 can cancel these 2. So our final answer is going to be t squared over r plus t all cube. So when you take your time to solve this problem, this is the final answer you supposed to get. And it is not difficult, as you can see. So now let's move on to look at how to solve this problem. That's problem number 3 under C. So now let's look at how to solve the problem number 3. This is how to solve the problem number 2, and it's very simple. So the problem number 3 is we have to simplify x plus 1 over x squared plus x minus 2 divided by, this is our division sign, x plus 3 over x squared plus 5x plus 6. So we have to simplify this question. So now let's take our time and simplify this question very well. So you see this side we have quadratic, this side too we have quadratic. So now let's factorize them. So we are factoring the denominators here. So you get s plus 1 all over negative 2 times 1 here is negative 2. So 2 factors of negative 2, that will add up to positive 1 is 2 and minus of what? 1. So you have s squared minus s plus 2s minus 2 divided by s plus 3 all over 6 times 1 is 6. So now let's look at the factors. The factors of 6, that will add up to 5. That's 2 and 3. 2, 3, 6, 2 plus 3 is what? 5. So we're going to get s squared plus 2s plus 3s plus 6. So from here you can group them 2, 2 like this, 2, 2 like this. So get s plus 1 all over s out, get s minus 1, 2 out, x minus 1 divided by x plus 3 over s out, s plus 2 plus 3 out, s plus 2. So now let's rewrite them again. We have x plus 1 all over the terms here, s plus 2 bracket s minus 1. This division, let's change this division to multiplication. So with reciprocal, this one will come top. I'm going to get s plus 3, s plus 2 all over x plus 3. The numerator has come down. So now let's take our time and do the cancellations. I think this is a factor, this can cancel. And s plus 2 here, I'll do the cross cancellation. So the remaining ones, they are going to get s plus 1 over x minus 1, where s is not equal to 1 as to be. So this is how to solve the problem number 3. And it is very, very, very simple to solve this question. So on this note, let's look at how to solve this problem. X plus 4 divided by s squared minus 4, s squared minus 16 divided by s squared minus 9 over x minus 3. So we are looking at how to solve s plus 4 over s squared minus 16 divided by s squared minus 9 over s minus 3. So on this note, I'll leave this question for you to solve it yourself. And when you take your time and solve it, you get the right answer. So thank you very much for watching this video.